would like to invite Mohammed Farzad Wazali. He's CEO, PANTOhealth GmbH. He's the managing director at PANTOhealth, holds a PhD in rolling stock engineering with over 13 years of industry experience. And he excels in R&D coordination performance, test design, and vibration analysis. At PANTOhealth, he leads the business and product development for predictive maintenance solutions in the rail industry. And today he's going to present on transforming infrastructure management, our journey with DBNets.
Good evening, everyone. So Farzad unfortunately could not join. He could not catch a flight. I'm Abhijit. I am from Muzdafar, India. We are their Indian partners. Well, I'm sure you all have had a sumptuous midday affair. It's 4:45 now, so imagine you're the maintenance guy. You're looking at your watch, you're waiting for your shift to get over, go home, spend some quality time with your family. But just then, you see your supervisor steps in, and he asks you to go for monitoring of the line. What do? So he is a companion who does the online monitoring for him, provides him of the abnormalities through notifications, abnormalities that is happening now or will be happening in near future, and it is happening real time. It is happening precisely at the location and exactly at the time he gets to know about it. So ladies and gentlemen, I would like to introduce PANTOhealth, and we would like to take you through our experience in handling a project with Deutsche Bahn in upgradation of their transportation infrastructure. This is in one slide. We're trying to put all what we have done. So who was the client? What was the problem? How did we investigate the problem? What did we propose to the client? What was the challenge during the design solutions? How did we overcome the challenge? Results, and finally, what was the customer costs and benefits and the next steps? So yeah, Deutsche Bahn, we all know, it's a German rail infrastructure company. They are the largest in Europe with over 33,000 kilometers of line. They do the maintenance, and they have also invested in cutting edge technologies to improve the efficiency and the reliability of the infrastructure. So what is the problem? The problem was they had the data, but the visualization of the data was not there. It was collected over a period of 6 months for high-speed rails and over a period of 12 months for the normal rails. Those data, they used to take it and they used to measure it when they needed to identify what was the problem and act on it. And after that, that data was in the dumps. The second problem was, again, the collected data is never real time. It is collected within a frequency of 6 months or 12 months. How did we investigate the problem? So we asked Deutsche Bahn to give us the data of 10 years for 100 kilometers of the line, and also access to the software that they're using to understand the current way of monitoring. We had the data, but then we had to do the benchmarking because there was huge data. While doing the benchmarking, so at that time there were two technologies that were there. First is the analysis of the accelerometers on the pantographs. So by using a shock detector on the pantograph itself. But here if you see, the shock detector only measures the abnormalities whenever it crosses a threshold. And the second option was to implement a vibrometer. Vibrometer, on the other hand, does a continuous capturing of the signals. Both has their advantages and disadvantages. The advantages of a shock detector is that it uses less data and also less battery. So you don't have to replace the battery very frequently. Vibrometer, on the other hand, it captures the continuous data, so it gives you more insights into how the whole pantograph and the catenary systems are working together. Based on this, they identified 5 solutions. We'll not go into detail, just on an overview from an infrastructure company. They would like to know the installation simplicity, the independency from the train and the pantograph, the maintenance friendliness, the signal collection capacity, the image processing, video from the interaction, and finally the capability of adding more sensors. I will go to the last one. The last one is basically what of all the solutions PANTOhealth decided to go with. It captures a roof-mounted camera, a platform for sensors that makes it modular. If you want to add more analysis, you want to add more sensors, that can be done. And finally, a vibrometer on the pantograph. Of course, the installation was complicated in this case, but your analysis capability was enhanced. As I mentioned, there was a sensor platform where you can add more sensors. So let's say we have a simple package where we can just give the accelerometers and the cameras. But then if we want, we can also add the scanners and the thermal cameras. Again, if we want, we can also add the lasers if we want to measure the thickness of the contact wires. What did we propose after getting the data? We wanted that the data should be integrated to the panel of PANTOhealth because that is a machine learning algorithm and a very modern database that they had. Also move the database into a modern database management system, and finally installing few more hardwares to get online monitoring from the running trains. But once we got the data, the big challenge was the amount of data that was there. I mean, just for 100 kilometers, there were more than 100 GB of data. The second was we had the modern database, and at the same time we had the monitoring data that was coming from the lines, and both were totally different. And putting all this data together to visualize the whole information within the dashboard was complicated. And finally, you have the data, you have the visualization. How do you find out what is abnormal during the monitoring of the system? To overcome this, so the whole data was divided into 2 parts, into hot storage and cold storage. Hot storage is what any person would like to see in front of him in the dashboard, and cold storage is background, whatever, as and when it is required, they could retrieve it. The second point was, because there was a lot of data, it was not easy to analyze all the data together. So they came up with an idea of point and abnormality. Abnormality is any deviations that you get when it crosses the threshold. Let's say we have a sensor that is measuring the zigzag of the line. There is an abnormality, so it will measure the abnormality. But at the same point, there are 2 abnormalities from 2 different sensors. It would be called a point. Based on this point and the abnormality, they could define and show everything on the platform. Secondly, how do they define the thresholds? The thresholds cannot be the same because you have got different regions, you have got different, say, environments, different configurations. So that is where, using their software application, they developed a digital twin. Now, digital twin is not same as a digital mathematical model of it, but digital twin which can have a dynamic behavior based on the simulations of the existing train set. Finally, the results. The results were it could have a platform where any maintenance person can see all the abnormalities in front of the dashboard. Also, not just see, they could also analyze which part is healthy, which is at risk, and which is unhealthy. This is just a simulation, simple for us to understand. There is a train, it moves, and if you see at point A and point B, it finds a abnormality. Then the train 2, as it moves, it finds fault in point A, B, and C. When the train 3 moves, it sees a fault. It doesn't see fault in A, it sees a fault in B, as well as it sees a fault in C. We have the 4th train. Again, it doesn't see fault in A, but it sees a fault in B, doesn't see a fault in C. And when it returns, it sees a fault in A, fault in B, no fault in C. Now, just from this, if I ask you, what do you think point A is? Is it healthy? Is it at risk? Or is it unhealthy? Anyone? Yes, it is at risk. What do you think of point B? Sorry? It's unhealthy, yes, at fault. And point C? It would be healthy because there is only one train that could find out. But we are talking this from the point of fault. But we did not measure the abnormality in the PANTOhealth itself. So if you see, even the the pantographs can have different faults. This is just a small data to represent how, let's say 100 GB of data has to be worked out through their machine learning and AI. They precisely can say which are the points where the maintenance team has to work now, or where they need to work as a preventive or proactive maintenance. What is the benefit? Of course, this whole system we supply on a subscription basis, the software, but roughly there is a saving of around 1,500 euros per kilometer per year. And that, when you measure, is a big one. The maintenance cost is not the only saving. Your reliability of the infrastructure increases because now you exactly know where the faults are, and also the availability of the fleet increases because your downtime really reduces using this application. These are just their system, their mathematical model. It was a fault, actual fault, because of the low incoming wire, and based on their software, they could precisely find out the exact reason for the failure. As and when the whole system is being used, it can define and identify and tell the maintenance team about the time when the predictive maintenance scheduling needs to be done. Thank you so much.